Okay, so this is the am I dying problem. This problem, you guys did a really interesting job of discussing this, and a lot of different ideas came up, and it can be a tricky problem, so I thought we'd just go ahead and lay this out in video form. So first of all, the important thing to think about with tests is you do have two outcomes. The test itself can be positive or it can be negative. So I'll write it this way. This is P is for positive, P bar is for negative. Now, in actuality, well, it's accurate if it says that you get a positive and you actually do have the condition. So we'll just call that D. So you have the disease and you test positive. Well, then there's also the indicator that you don't have the disease, and you can test one of two things, positive or negative. So there are really four outcomes here, four possible matchings of your actual condition versus the test result itself. Okay, so what do we know? Well, we know that the test is 99% accurate, so if you do have it, it'll catch it 99% of the time, and if you don't have it, it'll catch it 99% of the time. So this is an accurate cell right here, and this is an accurate cell over here. Okay, well, let's just suppose for simplicity that we have 100,000 people. Now, it doesn't really matter what you have down here. This could be 1 to represent 100%. The proportions will all be relative to 100, whatever your whole is. So remember, 99 out of 100 is the same thing as 990 out of 1,000 is the same thing as, well, there are many representations of the same ratio. So the ratio will be consistent. Well, we also know that 0.1% of people have the condition. So that means out of 100,000 people, 0.1%, that's 0.001 times 100,000, that means 100 people out of this population are expected to have the disease. Well, that means the other 99,900 are not going to have it. Okay, well, if you do have the condition, then it's going to be 99% accurate. So if you do have the given that you have the condition, 99% of the time it's going to catch it. So of these 100 people who have it, 99 of them are going to receive the positive test result that they do in fact have it. So that's going to be an accurate statement. Now, right here, same thing. This is an accurate outcome. You don't have, given that you don't have it, the likelihood that the test will say that you don't have it is 99%. So 99,900 times 90% 99%, excuse me, means that 98,901 people are going to not have it, and the test result will say they don't. So that means that one person who has the disease will falsely be told that he doesn't have it. And of the 999,900, take away the people who will have a negative result, 98,901, and that will tell you the number of people who get another false report. So that's the 1% of these people who are told that they have it when they really don't. So these totals, plus 99, will be 1,098, and this will be 98,902. Now the question is, what is the probability that a positive test result actually means you have the disease? So this really is asking, given that you have a positive test result, what is the probability that you have the disease? Okay, well, the number of people who test positive are 1,098. Out of those, 99 actually have the disease. So we're really staring at this column right here. Well, that comes out to 99 divided by 1098 means only 9% of people who test positive actually have the disease. So there are a lot of people being told, hey, you tested positive, but just because you test positive doesn't mean you actually have the condition. That means you should retest a number of times probably just to make sure that the test results are accurate. So with a lot of tests like HIV, they always say test more than once because a positive outcome doesn't mean that you have it. Now this is definitely true for really rare conditions, because if you look at this, only 100 people have it, but this number is a small number relative to the number of people down here, so that the percentage of the whole becomes really small. Now if this condition were less rare, like were equally split, we'd probably see slightly different results.